So this is the first question from the 2016 AP Physics exam, and the description reads as following. A wooden wheel of mass m consisting of a rim with spokes rolls down a ramp that makes an angle theta with the horizontal as shown above. The ramp exerts a force of static friction in the wheel, so the wheel rolls without slipping. In part A. On the diagram below, draw and label the forces, not components, that act on the wheel as it rolls down the ramp, which is indicated by the dashed line. To clearly indicate at which point on the wheel each force is exerted, draw each force as a distinct arrow starting on and pointing away from the point at which the force is exerted. The length of the arrow needs not to indicate the relative magnitude of the forces. So the first thing we have to do is to identify which forces is acting on this wheel, and we already know one of them because it was in the description, and that is the force of static friction. Also, the wheel has a mass, so we know it's going to have a force of gravity, and since the wheel is in contact with the ramp, there's going to be force normal. So now we just have to draw these arrows. And the first one is the force normal I've drawn, and it's going to be perpendicular to the ramp. So it's going to point a 90-degree angle away from the ramp. And then there's the force of gravity, and it's going to point straight down from the center of mass of the wheel. And lastly, we have to draw the force of friction, and since the force of friction causes the wheel to not slip, it's going to go up the ramp away from the wheel. And as I've drawn here. And an interesting thing is, in the rubric, this question was worth 2 points. So you would get almost a third of the points from just drawing this free body diagram and labeling it. We'll go on to the second part of part A, and it says, as the wheel runs down the ramp, which forces causes a change in angular velocity of the wheel with respect to the center of mass? And the center of mass. And change in angular velocity is caused by angular acceleration. And the thing that is acting on this angular velocity and angular acceleration is the force of friction, because it creates a torque. And I have written it out. And what I wrote was, the force of friction is the only force that exerts torque on the wheel with respect to the center of mass. And this is what's gonna cause a change in angular velocity on the wheel. Now we go on to part B, and it says, for this ramp angle, the force of friction exerted on the wheel is less than maximum possible static friction force. Instead, the magnitude of force of static friction exerted on the wheel is 40% of the magnitude of the force component directly opposite to the force of friction. Derive an expression for the line acceleration of the wheel's center of mass in terms of m, theta, and physical constants, so as appropriate. So the most important thing to note here is it says direct opposite to the force of friction, and so we say the force of friction is equal to 40% of the force of gravity. So that's what I've written out here. It says force of friction equal to 0.4 friction of gravity, which is equal to 0.4 mass of gravity sine theta. And now we have to make an expression or an equation. So I'm gonna write it out here, and then I'm gonna explain my steps. So it's the sum of force parallel to the ground equals force of gravity parallel minus force of friction, then equals mass of gravity parallel, and that equals mass of gravity sine theta minus mass gravity sine theta, which equals mass of acceleration parallel. And since they all have mass, we can divide by that. So it's just going to be acceleration is equal to g sine theta minus 0.4 g sine theta, which then is going to equal to 0.6 g sine theta. And then we go on to part C, and it says, in a second experiment on the same ramp, A block of ice, also with mass m, is released from rest at the same instant the wheel is released from rest, and from the same height. The block slides down the ramp with negligible friction. And the question reads, which object, if either, reaches the bottom of the ramp with the greatest speed? So we have to look, is it either the wheel or the block of ice who reaches faster? And since the block of ice, there's no friction, it's going to reach the bottom faster because the net force is going to be bigger because it's not going to experience friction like the wheel did. We briefly have to explain our answer in terms of forces, and this is what I've written out. Since the block of ice does not experience the force of friction, which was a counteracting force to the wheel, it will have a greater net force, which means it will have a higher acceleration. And then we go on to the last part of the question, and it says briefly explain your answer again, now reasoning in terms of energy. So we have to say why the ice block have a higher acceleration, but in terms of energy instead of forces. So both the block and the wheel has the same gravitational potential energy, and that's converted into kinetic energy. But the wheel also have rotational energy because it rolls, but the block of ice just slides, so it's going to have more translational kinetic energy. And this means it has a higher acceleration than the wheel has. And I'm going to write it out here to give my explanation. And it said both the block and the wheel has the same gravitational potential energy, which is converted into kinetic energy. The block has more translational kinetic energy than the wheel because the wheel also has rotational energy. The block is therefore faster. So now we have answered all parts, and an important thing from the rubric is that if you don't give an explanation, you're not going to get any points. So even though we had identified the block of ice, we wouldn't have gotten the points without explaining it like this.